right, in this video, we're going to take a look at a result of derivatives and how that will tell us things about extrema. Just a quick review of what extrema are. If I have a nice smooth graph like so, this green point looks like it would be a relative maximum since my function was increasing, peaked out, and then started to decrease. This blue point would be a relative minimum since my function was decreasing, bottomed out, and then started to increase. Notice also that at these points, we would have horizontal tangents, and we're going to come up with a general approach to finding relative extrema in the near future. For now, we're going to focus on when our function only exists on a closed interval. So we're going to have endpoints of our function, and we're going to identify absolute extrema for today. Notice that the points here, if I was to label them, point A would be a relative maximum, but point C would be the absolute maximum since that's the highest y value that my graph obtains from, looks like, say, x equals -6 up to x is a little bit more than 4. Point B would be a relative minimum, but point D, as in dog, would be an absolute minimum since that is the lowest point on my graph. All right, so we're going to tie all this together and be able to find any absolute extrema. First off, we need to know what critical numbers are. So this is anything that makes my derivative either 0 or undefined. Undefined because we could have those cusps or those corner or those sharp points on our function, and those are points where my derivative does not exist. So those are all critical numbers, anything that makes derivative either a 0 or undefined. We have a theorem. Anytime you are looking for relative extrema, they will only occur at those critical numbers. So we kind of need to know those things if we're looking for extrema. And then we have what's called the extreme value theorem. I shorten this to be EVT. It just tells us if we have continuity on a closed interval for a function, we are guaranteed that we have an absolute minimum and an absolute maximum. So you might be wondering, and I should emphasize on the closed interval is where those things happening. You might be wondering, how do we find these? So how do we find extrema of a continuous function on a closed interval? So again, this is for today, finding absolute extrema. So this is about a 4-step process. First thing, you need to find your critical numbers. You need to know when you have horizontal tangents or when your derivative does not exist. You want to evaluate your function at those critical numbers. And then this is the one that a lot of people forget to do. You want to evaluate also just your function at the endpoints of the interval. So like on that picture there, if I go back to it here, or the graph, that would be like points D and C. So be really careful not to forget to evaluate at the endpoints. So let me go back here. Once you evaluate your function at critical numbers and the endpoints, you want to then just compare. See which numbers are the highest and which are the lowest. Those are going to be your extrema. As a quick example, take a look at this 4th degree polynomial on the closed interval -1 to 2. Follow this 4-step process and try to identify the absolute extrema. And you can go ahead and pause the video, try this on your own. I'm going to go ahead and give the solution in 3, 2, 1. All right, here's my derivative, set equal to 0. Found my critical numbers, looks like 0 and 3/4. Then let me go ahead and plug into my function. F of 0 looks like it's a 5. F of 3/4 looks like it's 721 over 128, which is about 5.6 and some change. So it seems like my minimum would be a 5, and my maximum would be about 5.6 and some change. But like I said, that one step people forget. That interval, -1 to 2, I need to make sure that I evaluate my function at -1 and at 2. And if I do that, it looks like I actually get an absolute minimum of -43. And it seems like my absolute maximum was f of 3/4, which is about 5.6 and some change. That should do it for you and get you started on those questions on Schoology.